Here is another example for if you have to find the transfer function. Okay, so before you start, there's just name them the way they are. So this one is R1, this one is C1, this one is C2, this one is R2. So this is gonna help us not to make this to repeat the same mistake like the last time. So transfer function Vs V in S will be equal to, since there is a negative sign, we're gonna have negative there, negative Z2 over Z1. Where is Z1? This one is Z1, and this is Z2. Okay, so I'm going to write it in the form that you preferred. So it's gonna be Z2 times 1 over Z1. Okay, once you get something like this, we can now place the impedance of what you have there. Okay, so for this time around, what we're going to do is we're going to replace the value of what we have. Okay, so now if something is in series or in parallel, so it's gonna be, we're going to have negative here, so Z2, it's C2 in parallel with R2. Okay, Z1 is gonna be the impedance of R1 plus C1. Okay, so now we're going to write it in terms of Vs. Okay, so since we're working with S domain, I'm going to write it correctly so that you can see what's happening here. So you would get negative V C2 S in parallel with V R2 S over 1 V R1 S plus V C1 S, and you're going to replace them with what you see here. Okay, so you're gonna take this and plug it into those equations so that you can have now an idea of what you need to solve. So we'll get something like this. VC2, so replace VC2 is gonna be 1 C2 S I C parallel of VR I S R2 times 1, and then for VR1, so VR1 is gonna be I S R1 plus VC1. It's gonna be I think I'm running out of space, so what I'm gonna do is I'm gonna try to squeeze what I have here. I'm going to try to compress everything. Okay, so just I can get okay, so in this way it's fun. So what you're gonna get, what we're going to write here at the end is gonna be, this one's gonna be 1 over C1 S times the current. So this is what we're going to get here, and we have to work and work them out so then we can replace what we see there. So what I'm going to start, I'm going to take this block here and solve it out. So let's take this block here. Okay, so let's solve this block. And so what we said about when something is in parallel, this is the formula that we're gonna use to solve when something is in parallel. Okay, so we're going to have to write it in this way. Okay, we're going to have a fraction, so that'll be the first one times okay, there is one thing before we continue. I just remember, so since we have the current everywhere, we can cancel them out. So we can cancel out this current and the one at the bottom. We can also cancel out with this that you see here. So we can actually remove all the current. Okay, so we can remove all the current. This is the how we do about this question. We're not gonna keep the current, we just remove them, like simplify them. Okay, so we're going to have something like this. Okay, and then here 2 plus 1. Let me just remove this one. It's gonna be 1 C1S okay, so we'll get something like this. Okay, so this is what we'll be working on. So we actually don't need this current here, so we have this current here, and then so we're going to get to have something like this. Okay, so if I have to write this equation, it's gonna be times R2. Okay, so we're going to just write it in this way, S plus R2. Okay, so now we have something like this, and we do know that a fraction times another fraction will get we'll have something like this, 1 times R2, and here we're going to assume that we have 1 at the bottom, so it's gonna be C2S times 1, and here at the bottom we need to get the common denominator, which is gonna be this. It's gonna be this denominator divided by this denominator times 1. So we're going to have 1 plus, and here we're going to assume that we have 1. So it's gonna be this denominator times 1 divided by 1. So let's say this denominator divided by 1 times R2 is gonna give us R2 C2S. If you remove the denominator, you're gonna go back to the original fraction. And then next, what you're gonna get here is R2 C2S over 1 plus R2 C2S over C2S. And it said when you have one fraction over another fraction, it's gonna be like the inverse of that fraction. The first fraction times the inverse of the second fraction. So times the inverse of the second fraction. Okay, and this one is gonna give you what? It's gonna give you before you go, you can see that we have this two. They can cancel out. So you're going to remain only with R2 1 plus R2 C2 S. So this is what you're gonna put here. So whenever you have to write this equation, so we're going to have V out over V in equal to negative R2 1 plus R2 C2 S times, now we need to solve out the second block. Okay, so on the second block we have this fraction. Okay, now here we know that it's 1, we have R1 plus, we're going to assume that we do have 1 there, so we can get the common denominator. So meaning we're going to write this into a fraction. So it's going to be C1s, C1x divided by 1, it's going to give you this, times R1, it's going to be R1 C1s, and this one divided by this is going to give you 1, times 1 is going to give you plus 1. And if you have to write this equation, you're going to assume it's one fraction over another fraction. This is going to be, it's going to give us the inverse. So it's going to be 1 over 1 over the inverse R1 C1 is plus 1, which is going to give you C1s R1 CS plus 1 for the second blocks, and then you're going to come and replace it here. C1s R1 C1s plus 1. So this is what you're gonna get for both equation for V out. Okay, and also you can just work it out, okay, so that you have something clean. It's gonna be V out V in S. It's gonna give you negative R2 C1 is going to be 1 plus R2 C2 R1 C1s plus 1. So if I have to work out the denominator, I can just bring the denominator here and solve it on its own, so I can have one block. Okay, let's just I think I'm gonna need some room, but let's just go and see if it's gonna make a change. So now what you're gonna get here, it's gonna be this one times this one times that one, so it's gonna give you 1 times R1 C1s plus 1 plus this one times this one and times that one. It's gonna give you R. So start with this lowest one, R1, C1S, R2, C2S, and then plus R2, C2, S. So this is what you're gonna get, but except for the second one, S times S is gonna give you S squared. So I'm going just to write it correctly. So it's gonna give you something like this. Okay. R1, R2, C1, C2, S square plus R2, C2, S. So what you see there, you can put S in evidence. So maybe you can put this S in evidence with that S there. So then we can solve it out. So we get something like this. S R1 C1 plus R2 C2, okay, plus R1 R2 C1 C2 S square. This is when we're working with S domain, so we need just to pay attention to the S that we can take out, and the rest S and R, there are things that we can replace into our equation. So I'm going just to put the denominator. Okay, so this is what we're gonna get for our denominator, and then our numerator is gonna be R2 C1S negative VO V in S. And there is a way to cancel out the S. Remember we got S and there's I want just to check something. Okay, so this is what we have this idea, but there is something that we need to cancel out. Okay, so since we got this from this side, we took S and then we only have S square, so there is an option that we can go and there's also plus one, not just this is what's missing. You see this one here, okay, so the 1 times 1, this one times 1, it's gonna give us 1, so I forgot to add plus 1 here. Okay, so going to have plus 1 here. So in this final equation we're going to have a plus 1 there. Okay, so that's been said, so we're not gonna get so this is what we're going to get, and then I'm gonna write it in big format so then we can be able to see it. V in S equal negative R2 C1S S. You can even start with the square again in terms of power. square plus R C1 is R2 C2 S plus 1. So this is a transfer function that we got from this question. And then if you want to solve for V out, you can just send V in this side, and then you'll be able to solve it. So for this question, this is how we were able to solve it. Okay, so just to give you an idea of how we can go about solving these questions. Okay, so this is what we have. Now you can plug the value back, and those value, the one that you see that you're going to see here. So this is R1, this is C1, this is R2, and this one is C2. So you're going to plug them into this equation and solve for the transfer function. Okay, so this is all about this question. And then if you have to solve for V out, I'll already show you what you do. You're just gonna move V in times it to the fraction that side, and then you can get your times domain. Okay.